that occurred in the last few years. A similar giant crack was discovered in the Larsen C ice shelf in 2016. It was the fourth largest ice shelf in Antarctica at the time. Just imagine, it had an area of 17,100 square miles or 44,200 square kilometers, which is an area larger than the state of California. But this crack was about to break off an iceberg with the length of 68 miles or 110 kilometers, a width of more than 300 feet or 91 meters, and a depth of 1,600 feet or 500 meters. More mysteriously, by mid-2017, in less than a year, the rift had extended another over 20 miles or 32 kilometers to a point where only 2 miles or 3 kilometers of unbroken ice remained, and breaking was an absolute certainty. And in mid-July, the iceberg finally broke off from the Larsen C ice shelf, taking away almost 13% of the ice shelf with itself. And as of April 2020, scientists reported A68 has broken up into 3 pieces and is floating northwards towards open waters. When it broke, the iceberg was one of the largest ever, twice the size of Luxembourg, and weighed in at almost 1 million tons. What's driving these huge breakages in Antarctica? And is Antarctica safe for now? Scientists are still trying to figure out this anomaly. Smaller carvings of icebergs are regular occurrences all over the shores of the continent. These carvings are very much natural occurrences, as losing icebergs to the ocean is how these ice sheets maintain equilibrium, balancing the inputs and outputs from ice streams in and around them. However, such large carvings from major ice shelves are not consistent with the natural pattern at all. Such large carvings leave the parent ice shelves unstable and more susceptible to breakages. There can be various reasons for such phenomenon. One definite reason for such occurrences is the accelerated climate change due to the rise of greenhouse gases over the last few centuries. Since the Industrial Revolution, the concentration of carbon dioxide has been rising exponentially at a rate of about 0.17% per year. This change is primarily due to the combustion of fossil fuels, but also to large-scale tropical deforestation, which depletes the climate system's capacity for photosynthesis. Climate temperature changes depend on the variations in the amount of carbon dioxide in the atmosphere. Carbon dioxide controls temperature because the carbon dioxide molecules in the air absorb infrared radiation. The carbon dioxide and other gases in the atmosphere are virtually transparent to the visible radiation that delivers the sun's energy to the Earth. But the Earth in turn re-radiates much of the energy in the invisible infrared region of the spectrum. This radiation is easily absorbed by carbon dioxide. When the carbon dioxide concentration is sufficiently high, even its weaker absorption bands become effective and a greater amount of infrared radiation is absorbed. As it prevents its escape into space, the trapped radiation warms up the atmosphere.